homeworks. Aiden.
8 from worksheet 4.
Sure. So again, at this point, we've done worksheets 1, 2, and 4, Delta Math 1 through 16. Any of that stuff is eligible for questions. Right now, we're starting with number 8 from worksheet 4. So we start by thinking about the inside as our angle. So if theta is sine inverse of 1/2 x, sine theta should just be 1/2 x. And I remember that in a right triangle, sine is what sides? Ooh, this is taking too long. SOHCAHTOA, folks. There you go. That's what I'm talking about. But the question becomes like, what is this? Well, let's just multiply these two numbers together, right? X is x over 1 times 1 over 2, so that should just be x over 2. So opposite is x, hypotenuse can be 2. So far, so good, Aiden? You guys? Okay. We'll make that third side y, and then we'll use the Pythagorean theorem to come up with an equation for y. When I write the Pythagorean theorem, I have to be careful about which side. Hypotenuse, because it has to be the c. And a squared plus b squared equals c squared. So I'll just subtract x squared from both sides. I note that 2 squared is just 4. So I square root both sides. And there's my y. All right, so now what I have is tan theta, right? Which I know is in a right triangle, opposite over adjacent. So that would be x over root 4 minus x squared. And typically we don't leave a radical in the denominator. So just multiply the top and bottom by root 4 minus x squared. And that'll do her. Again, just to reiterate kind of the high level on this. So you start on the inside. Use that inside expression to create a right triangle. You label the right triangle. Use the Pythagorean theorem to find the third side in terms of x. And then you use the outer function, or use the right triangle to compute the outer function. Right? Does that feel okay? It's a general procedure. Who's next? Other questions? Okay. Let's dive into 4.2 today. We're going to do 4.2. We're going to finish 4.2 today. And that's going to finish up chapter 4 for us in general. This will be the last section. We're not going to do 4.3 from this chapter or worry about worksheet 7 from this chapter. Overall, I think 4.2 is pretty easy in that it's not really anything new. There is just 2 pieces of new vocab, and then otherwise, like mathematic concepts, there's nothing new that we haven't already done or talked about. So that's always kind of nice. So let's talk about these two new vocab terms. But I'm not going to define these in words. I'm going to define these kind of in pictures. So there's two terms we're going to talk about. They're called an angle of elevation and an angle of depression. So imagine we have two people, one person standing on the ground and one person standing up on a ledge. Both of these people we'll assume are just kind of looking straight ahead. So I'm going to draw like a dashed line for their line of sight, just looking straight ahead. And then I'm going to draw another dashed line for the line of sight for like when one of them is looking at the other. Everybody's okay with that? So if the person on the ground goes from looking straight ahead to tilting their head up to look at the person on the ledge, we call this kind of an angle of elevation. If you're the person up on the ledge and you're looking straight ahead, but then you tilt your head down to look at the person on the ground, we call that kind of angle an angle of depression. Now, the thing to remember with these angles of elevation and angle of depression is these angles are always in between the two lines of sight. The most common mistake students make is they want to put their angle of depression here. Is that in between two lines of sight? No, does not go there. That will be wrong. You'll get the wrong answer because your picture will be wrong and it'll be a problem. I'm warning this to you right now because come test time, you'll see a problem that includes an angle of depression, and a third to a half of us will put it in the wrong spot typically. I'm going to try to stop you from doing that right now by telling you that you're going to do it, and you have to be careful about it. See if you can help me out with that. All right. That's the only new idea. Let's do some examples here. All of the homework in this section is going to be story-based. So let's do a couple of examples here. Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top spire to measure 66 degrees. How tall is the Fisher Building? Okay. What do you suppose should be the first thing that we do here? Draw a picture, right? It's like a geometry-based story problem. There's an obvious picture involved. I'm not trying to win any art prizes. I'm going to say there's Christy, there's the top of the spire. They said there was an angle of elevation of 66 degrees, so that would be that. And it says we're 200 feet from the base of the building. So maybe I'll call this corner B for base. There's one other thing in here that I should draw into this picture that now the problem doesn't expressly tell us this, but from common sense and real life experience, we can assume this. What am I missing here in my picture? Somebody take a risk. What can I assume based on the situation and add to this picture? Grace. A right angle. That's correct. So we should be able to assume there's a right angle between the ground and the base of the building. Why is that? Yeah, you've been to lots of buildings before, right? When you walk up to a building, it's straight up and down on the ground, right? Unless you've been to Italy and you ran into one certain famous building. They typically are just straight up and down. That's the Leaning Tower of Pisa I'm referencing. Everybody's okay with that? So in general, in these story problems, if you're talking about a tree or a person or a building or any structure that would be standing on the ground, you can assume that it is perpendicular, is straight up and down. You know what I'm saying? Everybody's cool? Okay. What is it asking us to find then? Yeah, how tall is the building? Which side is that? SD or SB or SK? SB. Well, shoot, Mr. Kulik, this now just looks like a geometry problem, right? Where we're solving a right triangle. That's right. So based on this angle that we know, the side that we know is opposite, adjacent, or hypotenuse. Okay, and the side we want to know about is opposite, adjacent, or hypotenuse. Opposite, so the trig function we need is tangent. How did you know that? Opposite over adjacent, SOHCAHTOA, right? Mr. Kulik, do I still need to remember SOHCAHTOA? You betcha! So if you need to brush up on that, please do so while you're doing this assignment. All right. So now I just need to solve this equation for x. One way I could do that is think about this as two fractions equal to each other. That's called a proportion. The general technique for solving a proportion is to cross multiply. This is the only time you cross multiply is to solve an equation like a proportion. It's not a way to multiply fractions. So x times 1 is just x. And that should equal 200 times tan 66. And what do I do now? Calculator time. When I'm typing this in my calculator, though, I need to be careful. What do I need to be careful about? The mode. What mode should my calculator be in for this problem? Degrees. Excellent. How did you know? It's measured in degrees in the problem, right? It says 66 degrees. What mode has your calculator been in? Radians. How do we change between the two? Press the mode button, and then you'll make sure that your degree is highlighted. So just use your up and down, left and right arrows to move on to that degree spot and press enter to highlight it if it's not already highlighted. Then you can press second in mode to exit back out. And we'll just type this in as it's written. So I have 449.2 feet, and I'm done. Right? No big deal there. How'd that one feel? Should feel good, right? It's like, I can do this. This is a cakewalk compared to what you had us doing that last section, Mr. Kulik. I know. 4-3 is really bad, but we're not doing it. The honors kids do it. You guys don't. All right, next situation. Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? Okay, well, let's draw our picture. There's Jane. There's the base of the tree, which will make a right angle. There's Mary. Says Jane climbed 17 feet up. And then it says the angle of depression is 49 degrees. Where does that 49 degrees go? So right here. that what you're saying? Wrong! Is that between two lines of sight? No. Where's Jane's line of sight originally? Out there, right? So the 49 should be here. Alternatively, how else could we have drawn this triangle? Could also draw it that way, right? Or, if you remember from geometry, if you have two parallel lines, like Jane's line of sight and Mary's line of sight, that are cut by a transversal, we know that alternate interior angles are congruent. So we could label that as 49. That the angle of depression from Jane to Mary should be the same as the angle of elevation from Mary to Jane. Which should make sense, right? If you're looking down at someone and they're looking up at you, the angle that you had to move your head should be the same angle, because you need to be getting to the same line of sight. Everybody agree with that? Or you could have taken and made that angle 41, right? Why? How do I know that angle is 41? Because it's 90 minus 49. Yep. And then we're looking for how far is Mary from the base of the tree, so that's that side x. If we wanted how far is Mary from Jane, what are we looking for? Hypotenuse, right? If I just ask how far is Mary from Jane, straight line is the distance. That's the hypotenuse. Everybody's cool? Okay. All right. So let's just say that we drew our triangle, I don't know, use this one. So relative to that 49, the side we know is opposite adjacent or hypotenuse. Opposite. And the x is adjacent, so we need to be using tangent. So I can say tan 49 is equal to opposite 17 over adjacent x. Think about this as a proportion. Do my cross multiplying. So x times tan 49 should equal 17 times 1. And then to get the x by itself, what do I need to do? Yeah, divide both sides by tan 49. And then it's just calculator time. So what, 14.8-ish. How's this feel? Not too bad, right? What's the hardest part been? Really getting the picture right. You know what I'm saying? Art, guys. It's not really the drawing part. It's the figuring the words to picture is probably the hard part, not actually drawing the picture. That's just me being silly. One more example. This is the most complicated one. Oh boy, OneNote did not put that where I expected it to. All right. Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, meters, I guess you're in France, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? Okay. Well, let's start drawing our picture. So at point 1, we got our angle of elevation to be 32 degrees. We rode our little bicycle 100 meters closer to the base of the tower and measured our angle of elevation again, and now it's 37.5 degrees. And we want to know how tall is the Eiffel Tower. So we'll say that side. How you guys doing with the picture? Just the base of the building. B for base. Because that should be right angle, right? They didn't draw that. Good job. Take a look at the picture. Does it seem like we have enough information? Yeah. We don't know. Yeah, right? All we know is they got 100 meters closer. So when we look at this, or when I look at this, what I see is I see two right triangles. I see this right triangle here, and I see like this right triangle here. I'll call that, I forgot, call that P2. Everybody okay with that? Why am I not worried about the other triangle, P1, P2E? Why am I discarding that triangle? It's not a right triangle. Can I do SOHCAHTOA on it? Nope. That's why I'm not interested in it. Everybody okay? So I'm going to redraw these two triangles separately. Now, I need something to go here, right? We don't know how far it is from P2 to B. Seems like I'm going to need that. I'm going to give it a name. I'm going to call it Y. So how far is it from P1 to B now? What should that label be? 100 plus Y. Absolutely. And that's 32 degrees. So far, so good. I'll do the same thing. With my other triangle. How far is it from P2 to B? What should I call that label? Y. Notice in both of these two triangles, I have two unknowns, right? I have an X and a Y, both that I don't know. Is everybody okay with that? But these two triangles both have to be true at the same time, correct? Because they're both part of the exact same picture. So what I can do then is I can use these two separate triangles to create a system of two equations in two unknowns. So if I look at this first triangle relative to the angle 32, I have opposite and adjacent. Now if I look at the purple triangle relative to the 37.5, I have opposite and adjacent. So if I take these together, I have a system of two equations with two unknowns. Those two unknowns are X and Y. last year in Algebra 2, you would have talked about solving systems of equations. You would have talked about at least 3 methods to do so. Does anyone remember any one of those 3 methods? I don't know what that is, but it's really annoying. So can you see something outside, MJ, making that noise? I'm scared that it's the heating unit. Yeah, me too. All right, let's all do our best to ignore. Yes, of course. Oh, it's the landscaping. That's a leaf blower now, right? Or some kind of machine. Sounds like it was breaking. Anyways, okay. Names of techniques to solve a system of 2 equations. Substitution would be one of them. Great. Elimination would be another. The third one you never remember was the first one you learned would be graphing, right? You can graph them and find the intersection. And the one that you may or may not have talked about, you probably talked about some matrix methods to do this, whether you're solving a matrix equation or using Gaussian elimination or something. That was probably also a method you might have talked about, particularly if you're in the honors course. We're going to use substitution to do this. So my plan for this substitution is I'm going to take equation A and equation B and just get them equal to the same number or the same variable so that I can set them equal to each other. So if I take equation A and we cross multiply, 1 times x is x, and then 100 plus y times tan 32. That equation is now equal to x. If I take equation B, and we do the same thing, I get x equals y times tan 37.5. Notice now both of these 2 equations are equal to x. Does everybody see that? What does that allow me to do? I can take their right-hand sides and set them equal to each other. Notice that by doing this, I've created a single equation, one equation, that has only one kind of variable in it, just y's. No more x's. Everybody good with that? Now the hold up still here is that I have y's in more than one location, right? So in order to solve this, I need to move the y's from 2 different locations to 1 location so I can get the y by itself. Sound good? So to do that, what I would probably do is I would distribute the tan 32. So far, so good. Now I'm going to subtract the tan 32, or the y times tan 32 over. But how do I do that? Y tan 37.5 minus y tan 32. cancel out the signs?
No, like the sides. Like you did it on the left side.
Yeah, I mean like,
Yeah.
yeah. But how do I subtract tan 37 point, or how do I do the subtraction between tan 37 point, sorry, y times tan 37.5 and y times tan 32? What do you mean by plug it in? I don't have, there's a variable on it.
Oh, this is a lot.
So tan 37.5, just a number, right? That's a number you could type in your calculator. Tan 32, just a number, something you could plug into your calculator, right? So instead of thinking about that as like tan 37.5 and tan 32, what if it just was like 5y minus 3y? How would you do that? 2y. How did you get the 2? You did the 5 and the 3, subtracted the 5 and the 3. So what are we going to do here? Same idea. I'm going to subtract the coefficients. Is that okay? See what I did? Just like 5x minus 3x is 5 minus 3 in parentheses x, or 2x. Did the same idea there. That's kind of sneaky. Now to get the y by, now the y is now in one spot, right? I have just one y in my equation now, instead of having two separate y's. You see? How do I get the y by itself? If it was 2y there, what would I do to get the y by itself? It was divide by 2, right? So what am I going to divide by this time? That giant thing. Perfect. Excellent description. So y equals 100 tan 32 divided by tan 37.5 minus tan 32. Now, to type this into my calculator, doing this could be a little bit tricky, right? To do this in one line on my calculator, I'm going to have to do like some crazy parenthesing. Or I can use that horizontal fraction bar like I've shown you guys before. That's what I'm going to do. So I'm going to press alpha, y equals, and then choose option 1. That gives me the horizontal fraction bar. So now I can just type this in exactly like it looks like on my sheet of paper. Don't need to do anything fancy about it. And that's good because I'm not a fancy guy. Like, let's keep it simple, right? If it can look just like it is on my sheet of paper on my calculator screen, then I can be pretty confident I typed it into my calculator correctly. So there's my answer, 438.6. Am I done? Well, there's two variables in this, right? There's x and y. We really only wanted one of them. Which one did we want? Let's go back and look at the picture. Oh no, we wanted the height of the Eiffel Tower. I want x. I found y. How do I get x? Yeah, pick one of the two equations and plug the y back in. If you had your choice between equations A and B, which one would you choose? B. Why? because it looks simpler, right? The fraction doesn't have any crazy stuff going on in it. Let's just do that. So we can say tan 37.5 equals x over, and instead of y, I'm going to type in 438.6. Do my cross multiply. And then it's just calculator time. So I'm going to take that answer that I just got and multiply it by tan 37.5. So 336.6. And that's our answer. That's as bad as it gets. And again, the hard part about this was the algebra piece, right? Was going and solving the system and walking through that algebra. So for you guys, for homeworks, you guys are going to do worksheet 3. So I got 6 story problems there. And you guys are going to do 17 to 23 from the problem set. So let's kind of summarize what we have so far. So problem set 1, which you've already turned in, hopefully, was worksheets 1 and 2. That was what was due on Sunday. And for problem set 2, what do we have? We had 1 through 16 from the asynchronous day. We have worksheet 4 and the delta math. That stuff is due this Sunday. And then problem set 3, which is going to include 17 to 23, worksheet 3 and the review, that'll be due the following Sunday. And then what's due on Friday, though? Yeah. Now, when you're making your half sheet, as a suggestion, that most recent example that we just did, I might like to have an example of that on my half sheet, right? That was kind of complicated, the algebra piece of it. Be nice to have something to follow along. So I might include either this example 9 from the homework or from the notes, or I might include my solution to problem 6 from worksheet 3, or problem 23 from the problems, or question 7 from the review. But I'd probably want to have like one of those on there somewhere, because that process is a little bit tricky, and I'd want to make sure I had the practice or an example of that. This is the end of what we're doing in chapter 4. Friday is going to be our review day. What does that mean afterwards? Well, what happens to class after a review day? Test. Now, I'm not insane. We're not going to have the test the day you come back from vacation. We're going to have it the second class day after you come back from vacation. So I'm just going to start the next chapter on Tuesday when you guys are back from vacation. And then we'll take the test the following day, or the following class. Everybody's okay with that? But the half sheet is due Friday. And I mean it as due Friday, not like, oh, you can turn it in later. Like, I mean it due Friday. Why am I being a stickler about this? None of you are going to remember to do it over vacation. And then you're going to come in on Tuesday and be like, where's your half sheet? And you're like, oh, I don't have it yet. And you're going to throw something together like at the last minute because you forgot about it. I'm going to help you not be able to forget about it. And we're going to just have it done before we go on break. Does that sound okay? Okay. So I'm done talking here. For the remainder of class, you can spend your time working on, if you still have to catch up on problem set 1, good Lord, get that done and turned in. Send me an email if you haven't done that, if you haven't finished it yet and you finished it. You can work on your problem set 2 stuff. So worksheets 4, 1 through 16, the Delta Math. Or you could start your new stuff, 17 through 23, worksheet 3, the review. Or you could start working on your half sheet. Any of these would be acceptable to use this final 40 minutes or so of class to do. Any questions for me at this point? Clear what to do, Win? What you got to do? Yes. Sure. You can go with her. Just use separate stalls. It'd be weird otherwise.
Okay.
Okay.
No, we plan on going.
I'll be here on the 3rd. I'll be in at Kairos.
Okay.
So
We'll worry about it when you get back. Unless you desperately want to take it before that, we can just worry about it after.
I just want to let you know.
Yeah, no, I appreciate that.